So Muneeb, Maheen, is this idea clear? Is this question clear?
Yes, sir.
Yes, sir.
ये उसी तरह था जिस तरह we figured out that like fragmentation pattern, like you had a fragmentation pattern where there was a particle which had a mass of 14, 16. Then there were particles with masses 28, 30, and then there was this big ion, which is the molecular ion. So if you can figure out the smaller pieces and you can build the bigger pieces, and if you build the bigger piece, that's your molecular ion. I mean, for example, the smallest piece would be carbon. You can, and carbon would be 12, so there would be detection at 12. Then there would be 14 as well, so that would probably be, you will be able to figure out that CH2. Then there might be 15, so that's CH3, and so on. You can figure out CCl3, and then maybe you can figure out the bigger piece as well. So in this case, this is how you're going to do. Now in this class, we'll try and do. Now HNMR is something that belongs to A2. So I think I've shared the board link, but this is not in your course at the moment. There's another analytical technique which is part of AS, and that one is, let me do it over here. So that analytical technique is infrared spectroscopy, and it's kind of very easy. So that's really a very simple technique, and you don't get big questions on this. So just quickly doing infrared spectroscopy, then we can do some past paper questions. So what is infrared spectroscopy? So the idea is basically that molecules have different shapes, right? If you have a molecule that has 4 bonds, it's tetrahedral. So this one is tetrahedral. So this is like if I CH4 molecular shape. So the geometry of the molecule would kind of look like this. One second. I mean, if a molecular shape model. So anyways, let's take this shape. So the point I'm trying to make is that if you have a molecule, the bonds are as far away from each other as possible. So it's like a pyramid with one bond on top, sticking on top of it. What happens is that that the bonds are not always rigid. Any shape, if you take any molecule and any shape, the bonds, they vibrate. Why? Because they're always flying around and they're colliding with other particles as well. So there are lots of CH4 molecules and they're bumping into each other, they're bumping with the walls of the container, and the bonds are always stretching, compressing, and they're bumping into each other. So it's like they're not always rigid. So they vibrate to and fro. When they gain energy, when they bump into other molecules, other substances, they stretch and they compress. So they're kind of flexible. Okay, so is this idea clear that the shapes of the molecules are not very rigid? They're kind of, I mean, these bonds are kind of swinging around. They're stretching and compressing as well. Is that clear? You clear, Aisha, Maheen, Umar? Is this clear, Muneeb?
Yes.
Achha, so
Yes,
the first thing is the bonds can gain energy, just like a swing. Like if there's a swing, बच्चों के playground में if there's a swing, they're going to swing to and fro just like a normal swing. And they can also do that. They can also absorb energy from infrared waves. They can absorb energy. So the infrared frequency is something from which they absorb energy. And remember, energy is proportional to frequency. Every bond will have a unique frequency at which they would vibrate. Okay, think of a swing. If you think of a swing, in the swing absorbs energy. I mean, no, it swings around when it's energetic. So the swing starts to move to and fro, right? And let's say there's a person standing over here, and that person is basically pushing the swing. It's giving it energy. Now, all elementary particles, they vibrate. The swing also vibrates. I mean, energy is basically vibration. All types of electromagnetic waves. What is happening in a wave when energy is being transmitted? It's basically a vibration of particles that's going on. Now, the swing, if you know what a swing is, it will absorb energy at a specific frequency. If there's a person who's transmitting energy to the swing, he has to apply energy at a very specific point with a very specific time period. You can't just go on, start pushing it randomly. It has to be done with a very specific time period. It has to be timed properly. And then you can only push the swing, because otherwise the swing will not absorb energy. Like if the swing is coming back and he decides to push it, the energy would be transmitted back to the person. It's not going to be absorbed by the swing. I mean, if the swing is coming down with a lot of speed and you decide to sort of push it and give it energy, it's not going to accept it, right? Is that point clear?
Yes, sir.
Okay, so the point is, okay, all vibrations, they absorb energy. All particles that are vibrating, they absorb energy at very specific frequencies. So the same applies to bonds. If these bonds are going to swing and they're going to absorb energy and they're going to start vibrating, they would do that at a very specific frequency. Just like your normal playground swing, it absorbs frequencies. It absorbs very specific frequencies. It doesn't absorb any random. I mean, you have to time it properly. Okay? Munib, is clear? Maheen, is this clear?
Yes, sir.
So just remember, these bonds, they would absorb very specific frequency, and every bond is different, just like every swing is different. Every bond, like there's a double bond, every bond has a different bond length. Okay, so I mean, if you have a different swing, it's going to have a different time period. You would have to push it at a different time interval, and you would have to give it a different frequency, right? So the point is that every bond is unique, and every bond is going to have a different frequency. It's going to absorb a different frequency from the infrared spectrum. And otherwise it's not going to absorb frequency. It's going to reflect it back, which is why when you shine light on objects, the light gets reflected back, because I mean the object has decided not to absorb those frequencies. So the point is that if I have a molecule, so let's think of a molecule, an actual molecule. The molecule will have many different bonds. Some of the bonds would be of almost the same type. So for example, I have this molecule. So the C double bond O is kind of, I'm just writing the individual bond. C double bond is a unique bond. So that would vibrate at a frequency which would be different from all the other bonds. It would vibrate, it would absorb a different infrared frequency. If you have a CH bond, that is also going to absorb a different frequency. If you have a CC bond, it's going to absorb a different frequency. So you'll have a frequency spectrum, and by looking at the frequencies that they're absorbing, you can figure out what bond this is. So although you won't have a data booklet now, the table would be printed with the question now. But if I open the data booklet, just a second. So if I open the data booklet, now these values would be given in the question. So the question would be, I mean, different infrared absorption frequencies for some selected bonds are given. This is known as wave number. Just, I mean, you don't have to go into details about wave numbers, but just think of wave numbers as 1 over lambda. A wave number is 1 over lambda, which is not equal to frequency, but it's proportional to frequency. If you know V is equal to lambda f, So this one. Think of this as frequency. So there would be one axis, and you'll be told that if there's an absorption at the 1040 1300 wave number, that would indicate that it's got a C single bond O. This C single bond O is present in many different molecules. It's present in alcohols, ethers. You don't know what ether is. That's not in your course. Esters have C double bond O. Like if you look at an ester has this functional group. So it's got a C single bond O. Similarly, C double bond C, it's present in alkenes and aromatic compounds. Aromatic compounds are basically your benzene rings. And I think I told you that when you think of benzene, think of 6 carbon atoms with alternating double bonds. But anyways, alkenes and aromatic compounds are kind of structurally, they're kind of very similar. So aromatic compounds are not in your course at the moment, they're in A2, but think of whenever you see a benzene, although that's not in your course, but whenever you see a benzene, think of it as an alkene with alternating double bonds. It's not really an alkene, but kind of very similar. So uski absorption range ke, that's 1500 to 1680. Amides, ketones, aldehydes, esters, they all have C double bond O. Alkynes have C triple bond C. Nitriles. So all the absorption frequencies are given. And the appearance of the peak is also given, that there's a strong absorption. That means, strong means strong, that the frequency will be, I'll explain what strong means. W means weak, that it's going to get absorbed, but not that much. So usually the peak is strong or weak. And there's a broad absorption as well. So I'm going to explain the shapes of all these peaks. So let me just, that's about it. That a molecule, that's pretty much it. So a molecule will have many different bonds, and all these bonds will have a unique absorption frequency in the infrared spectrum at which they would start to vibrate and they would absorb those frequencies. Okay? Is that part clear? Clear, Sarah?
Yes, sir.
Yes.
अच्छा तो उस पे चले जाते हैं कि 1 second. One infrared, right? So वैसे नेट पे देख लेते हैं 1 second. Actually, the questions are kind of really simple. ठीक है, और 1-2 मार्क का क्वेश्चन आता है. Maybe नहीं, that's an examiner report. इससे स्पेलिंग तो गलत नहीं है. अच्छा वो डैश है. So इस पे देख लेते हैं. वैसे क्वेश्चन आ गया, I'll just show you. हाँ ये आ गया. So this one. Achha, here's a question on infrared spectroscopy, and it's going to be linked with organic. क्योंकि organic chemistry से इसका mostly वो carbon के compounds, so it's linked with organic. So it's saying when a reacted X is treated with, so this is the infrared spectrum. These are your wave numbers, and what you're going to see is ये जो dips है ना, that's your absorption. So let's call this F naught. There's a frequency 3000 wave number that's getting absorbed, right? So so he's saying that there's a reactant X is treated with suitable reagents. Product Y and Z are formed. Infrared spectrum of X, Y, and Z are shown, right? So that is X, and this one is Y. So if you look at product Y, there is something, let's call this, I think that's 1700, right? Approximately. So there's a strong, this is known as a strong absorption, right? So the appearance of the peak is strong. This one is also kind of strong. I'm going to write S with it. Okay. Achha, over here, there's another one over here. This is also around 1700 wave number that's getting absorbed, and that's strong. Now this one is broad, somewhere around up till 3500, somewhere between 3000. In this range, there's this strong and broad absorption. ठीक है, is the idea clear? कि appearance वाला part clear है? ठीक है, is this clear?
Yes, sir.
Yes, sir.
अच्छा, अब इसका करना क्या है? अब इसका करना ये है. अच्छा, remember one thing, you can't really figure out much in infrared spectrum to begin with. ठीक है, I'll tell you which bonds to look out for right in the beginning. Here are all your bonds. So it kind of gets confusing because there's so many absorption peaks, right? So the ones that are uniquely identifiable are the ones, is this one. ठीक है, इसको बल्कि याद कर लो. Make sure you remember this. This is there's going to be an absorption, a strong absorption, whether it's an amide, ketone, or an ester. They all got serial bond O's in them, and they would have an absorption. So you can't be very specific because all of them have overlapping ranges. Okay, 1690 or 1670 or so you can't really tell, is that serial bond O belonging to amide or is it belonging to ketone? So you can't be very specific, but you can identify a serial bond O. You wouldn't be able to identify which one it is, but you'll be able to identify serial bond O. So there's going to be a strong absorption. So एक तो इसको सबसे पहले इसको ढूंढना है, ठीक है? So if I go back to the question, is this 1600, 1700, right? So which peak is this? This is serial bond O, right? Clear?
Yes, sir.
और यहाँ पे भी वही है कि there's a strong absorption at around 1700, so that must be serial bond O. तो इसका मतलब है इन दोनों के पास ना product G and product Y, they both have serial bond O. ठीक है, is that part clear? सारों को clear, मुनीब? Or,
Yes, sir.
अच्छा, where's the data booklet again? So and their numbers are kind of different from all the other ones. Achha, next one. और कौन सा uniquely identifiable है? The OH. And the OH specifically belonging to carboxylic acid. It's got a strong and very broad absorption between the 2500 and 3000 range. Broad एक ही की है, मतलब और किसी की broad नहीं है, ठीक है? So whenever you see this broad absorption, broad है ना ये, अब उसी range में 2500 to 3000 somewhere, and remember the ranges are not exact. It's approximately the same area, right? So whenever you see a broad absorption, that's an OH belonging to a carboxylic acid. ठीक है, is that clear? You clear?
Sir, can you repeat it?
Yeah, I'm just saying कि जो unique bonds identify कर सकते हो ना आप इस पूरे में, don't look for the other ones. Look for these two first. कि serial bond हो, वो वाला तो clear है ना? मैंने कहा कि जो bonds are uniquely infrared spectrum में ना, it's very hard to actually identify different bonds, right? You get these other absorptions होंगी, you won't be able to figure out a lot. तो जिनको सबसे पहले target करना है ना, that is serial bond O, and the other one is OH. OH belonging to carboxylic acid में भी OH है. And alcohol has OH. Achha, this alcohol, hydrogen bonded alcohol, is basically alcohol that's aqueous, ठीक है, mixed in water. Free alcohol is just alcohol, ठीक है. तो लेकिन उनकी absorption range almost same ही है, ठीक है, तो इतना कोई फर्क तो है नहीं. But anyways, you've got OH belonging to carboxylic acid, उसकी 2500 to 3000 के बीच में कहीं ना, there's going to be a strong and very broad. So I was saying कि broad absorption जो होती है ना, वो किसकी होती है? OH की होती है. बाकी every other one, there's no broad written. ठीक है? The appearance of the peak is not broad. So whenever, so OH is clearly identifiable, easily identifiable. So whenever you see this, okay, there's a broad absorption, 2500, 3000 की range में, so that must be an OH that belongs to carboxylic acid. ये clear है?
Yes, sir. Oh, I get it.
ठीक है. So अब ये कि what do you do with this? What you do with this is कि you figure out that this is a carboxylic acid क्योंकि ये जो Z है ना, that must be a, अच्छा, it must be a carboxylic acid, right? And how did we figure that out? क्योंकि it has a acetyl bond O, plus it has an OH belonging to carboxylic acid. तो वो दोनों चीजें इसी में हो जाएंगी ना कि if it's a carboxylic acid, it's got a acetyl bond O, plus it also has a OH that belongs to a carboxylic acid. तो आपको ये पता लग गया कि this one is a carboxylic acid, ठीक है? अच्छा, फिर ये क्या है? This is, it's got acetyl bond O. फिर एक 3000 में ना, there's a weak, very weak peak. So what does that come from? तो again open the data booklet. Weak जो होती है ना, वो CH के bonds की होती है. They have weak peaks. ठीक है? They've got weak peaks around 3000. So it must be the CH bond. This one over here must be the. तो ये बाकियों की इतनी टेंशन नहीं लेनी. सबसे पहले इसको आइडेंटिफाई करो, इसको आइडेंटिफाई करो, ठीक है? So this one over here must be, I mean, this must be CH, and every molecule has CH. I mean, kind of almost every molecule has CH. तो उसकी weak C peak है. अच्छा, यहाँ पे क्या है? There's a very strong peak at 3000, and I have no idea what this is. Okay, even if I look at the data booklet, remember infrared spectrum कोई ज़्यादा आपको नहीं बताता. So there's a very strong peak. Maybe it's CH, क्योंकि that also has a strong peak. Alcohol की strong and sharp होती है, but it's much further away. So I know, at least I know it's not an alcohol क्योंकि उसकी 3000 से आगे आती है peak. So I know that this is definitely not alcohol. मुझे ये भी पता लग गया कि there is no acetyl bond O in it, and there is obviously no OH. ये तो clear है ना कि there is no OH, क्योंकि 3000 पे अगर OH होता ना, तो OH would be either a strong or very broad, और वो फिर 3000 से आगे आती, ठीक है, if it's an alcohol. So अब आ जाते हैं क्वेश्चन पे. उससे क्या है कि is treated with so they didn't tell us what the reagent is. He's just saying that there's this molecule, and that molecule breaks down into these two things. That's kind of about it. तो कह रहे क्या हो सकता है? अब you've got several options. एक तो हमें कंफर्म पता लग गया कि there's a carboxylic acid. Z is a carboxylic acid. तो यहाँ पे ना उसने दिए भी 3 options हैं. तो we know कि Z is a carboxylic acid, right? अच्छा, we know that this one over here is definitely not a carboxylic acid. तो ये निकल गया. अब कौन से options रह गए? B and D. Eliminate करना पड़ेगा because with infrared spectroscopy you can't be exact. अच्छा, alcohol भी निकल गया. It can't be an alcohol. Why cannot be an alcohol? क्योंकि alcohol की, अच्छा, alcohol की peaks जो है वो सारी missing है. Clear है?
Yes, sir.
अच्छा, 2 मिनट रुकते हैं, अजान हो जाए. अच्छा चलिए वापस इस पे ये कंफर्म था दिस इज अ कार्बोक्सिलिक एसिड, तो वो 3 ठीक होंगे, ठीक है। This is confirmed not a carboxylic acid. There is no OH, क्योंकि OH remember 3000 के इर्द-गिर्द या तो स्ट्रॉन्ग पीक्स होंगी, लेकिन वहां पे कुछ भी स्ट्रॉन्ग नहीं है, ठीक है। तो इसका मतलब है OH गायब है यहाँ पे, देयर इज नो OH, ठीक है। लेकिन सी डबल बॉन्ड O है यहाँ पे, तो इसका मतलब है कि एथेनोइक एसिड और प्रोपेनॉल दोनों निकल गए Y के अंदर से। तो पीछे ऑप्शन कौन सा रह गया? सिर्फ और सिर्फ ऑप्शन कौन सा रह गया? दैट्स बी, क्योंकि आपने सिर्फ Y और Z को ही चेक करना था, Y और Z तो कंफर्म हो गए, ठीक है। तो द ओनली ऑप्शन पॉसिबल is B. Is that clear?
Yes, sir, but can you compare this with graph?
हाँ वही मैं कह रहा हूँ ना कि ये कौन सा, ये कार्बोक्सिलिक एसिड है ना।
No, sir, the first one.
अच्छा इस वाले को, अच्छा मैंने इसको
Yes, sir.
एक्स को तो मैंने डिस्कस ही नहीं किया, मैंने कहा एक्स तो वैसे ही बाय डिफॉल्ट ये आ गया ना। ये तो क्लियर है ना, ये Y और Z क्लियर है। मैं एक्स पे आता हूँ, Y और Z क्लियर है।
Yes, sir.
अच्छा और बाकियों भी क्लियर है? मुनीब, माहीन, इज दिस क्लियर?
Yes.
Yes, sir.
अच्छा 2 methyl pentoene, right? That was the only option that's वो फिर एक रह गया। So this is 2 methyl pentoene. Pent कितना होता है? That's 5 carbon atoms. 2-ene means double bond on the second one, and 2 methyl, तो second के ऊपर ना there's another carbon atom, ठीक है। अच्छा वो हाइड्रोजन ड्रॉ नहीं करते, इसको सिंपल रखते हैं। अच्छा ये मॉलिक्यूल है, तो इसका मतलब है ये मैंने कहा था ये क्या होगा, मैंने कहा था OH तो हो नहीं सकता, क्योंकि वो मैंने पहले कहा था ना जब हम तुक्के लगा रहे थे, मैंने कहा था इसमें सीडल बॉन्ड O तो है नहीं, देयर इज नो सीडल बॉन्ड O, क्योंकि सीडल बॉन्ड O इज एट 1600, ठीक है। तो वो भी नहीं था। एंड OH अगर वो 3000 पे होगा ना, तो इट मस्ट बी अ स्ट्रॉन्ग एंड वेरी ब्रॉड पीक, तो वो भी नहीं थी। And the alcohol OH wasn't there, क्योंकि that was higher than 3000, ठीक है। So this was exactly 3000. Must, I told you it must be the carbon and hydrogen bond, क्योंकि वो 3000 पे open है, they also give a strong peak. So it must be, it probably is that, ठीक है। So तो वही निकली थी कि it's an alkene, तो ये बाकी H होंगे ना, ठीक है। ये सारे इसके साथ H होंगे। तो क्लियर है कि ये जो नॉट एन अल्कोहल वो भी सही था, नो सीरियल बॉन्ड वो भी सही था। तो बेसिकली 3000 पे जो आप तुक्का लगा सकते थे वो H का ही लगा सकते थे, must be CH, और वो ढेर सारे CH है, so there's a strong absorption in this range. Is this clear? ठीक है, ये क्लियर है?
Yes, sir.
अच्छा फिर रिएक्शन, व्हाट इज द रिएक्शन दैट्स हैपनिंग? मतलब मैं what happened, when does an alkene split into 2 different products? तो उसके लिए I'll just refer to the chart कि when you have an alkene and you heat it, उससे कोई reagent वगैरह कुछ नहीं बताया था, so the only thing is you were only able to guess। तो हम वो भी guess कर लेते हैं, although उसने कहा तो नहीं है, लेकिन उसने सिर्फ identify करने को कहा था। But we'll go a step further. There's an alkene, strong oxidation. What happens? The double bond splits. If the double bond carbon had 2 carbon chains, it will turn into a ketone. If it's got 1 carbon chain, it will turn into a carboxylic acid. If it's got no carbon chain, it will turn into carbon dioxide and H2O. So I'm going to do exactly that with this molecule. Okay, what will happen is कि इसका जो double bond है ना, that will break in the middle. ठीक है। ये वाला कार्बन जो है इट्स बॉन्डेड टू 2 कार्बन चेन्स, मतलब बीच में से ना इन 2 कार्बन एटम्स को हम हाईलाइट कर लेते हैं, ठीक है। सो फ्रॉम द मिडल द डबल बॉन्ड हैज ब्रोकन, वो भी चला गया, एक सेकेंड। अच्छा ये दोनों कार्बन्स, द डबल बॉन्ड हैज ब्रोकन, दिस वन हैज 2 कार्बन चेन्स। इफ इट्स गॉट 2 कार्बन चेन्स इट विल टर्न इनटू व्हाट, उसमें क्या लिखा हुआ है? इफ इट्स गॉट 2 कार्बन चेन्स इट विल टर्न इनटू अ कीटोन, सीरियल बॉन्ड O बन जाएगा ये, ठीक है। So this one will turn into a ketone, मतलब C double bond। और ये वाला जो कार्बन था ना दूसरा, the one that was making the other double bond, that had 1 carbon chain. So if it's got only 1 carbon chain, this one will turn into a carboxylic acid. अगर वो notes देखो, so if it's got 1 carbon chain, that will turn into a carboxylic acid. So this one, it will turn into double bond O and OH, ठीक है। वो कार्बोक्सिलिक, मतलब ये 2 अलग अलग मॉलिक्यूल्स हो गए, बीच में से So one of them is propanoic acid, the other one is propanone, क्योंकि 3 carbon atoms and it's a ketone. The middle one has a double bond O. Is that clear? और उसने वही कहा था कि it's a propanoic acid and propanone. One of them is a ketone, the other one is a carboxylic acid. ठीक है, clear है?
Yes, sir.
अच्छा, बाकी है कि so that is infrared spectrum. So remember, I mean, this is a good question actually. So we'll just try and do it थोड़ा सा detail because they had mixed it up with organic a lot. So we'll try and do हर paper में ही होता है वैसे. एक question होता है हर paper में. So let's try and see if this paper has one question. अच्छा, ये आ गया infrared. So the table shows the molecular formula of. So remember, infrared में ये चीज याद रखना कि सबसे पहले what are you going to see? ये बाकियों को छोड़ दो, बाकियों का कोई पता लगाने से कोई फायदा भी नहीं होना. सीरियल बॉन्ड ओ फिगर आउट करो, या तो वो होगा या नहीं होगा, और यू फिगर आउट OH whether it's there or it's not there. ठीक है, इन दोनों पे ही फोकस करो. बाकी फिर अगर ये दो नहीं है ना, तब मसला पैदा होगा और तब जाके फिर दूसरों को देख लेना, लेकिन इन दोनों से ही काम चल जाएगा. ठीक है, because these are easily identifiable. So let's do this one. Question is, the table shows the molecular formula of 3 molecules P, Q and R. None of the molecules are cyclic. So ठीक है, which molecule show a strong absorption between the 16. अच्छा, ये बताओ कि 16, 10, ये मैंने क्या बताया, 16, 10, 17, 50 in the infrared spectrum. So which molecules 16, 10, 17, 50, ये वही बन गया serial bond O. 16, 10, 17, 50, it's the same absorption range, strong. Is that clear? So it must be either in serial bond O होगा उसमें. ठीक है, clear है ये?
Yes, sir.
तो आपने जाके बस देखना है कि किसके अंदर ना, और उसने he didn't give us any information about the structure. अब ये वाला जो है ना, this one, ये तो definitely serial bond हुआ है, क्योंकि that's और कुछ हो ही नहीं सकता, क्योंकि there's 2H और फिर there's a double bond, मतलब O के साथ डबल बॉन्ड ही रह गया फिर, तो ये तो हो गया. It will. अच्छा, CH2O2 है, इसका पहले सोचो कि स्ट्रक्चर क्या होगा. थोड़ा सा मुश्किल होगा कि C, there are 2 hydrogens and 2 oxygens as well. वैसे इसका किस तरह का स्ट्रक्चर होगा? CH2O2, there's only one C. I have to fit 2 oxygens. तो अगर मैं OH कर लूं, right, और एक तरफ मैं I put the other oxygen, हाँ हो गया. कब मेथनोइक एसिड था. अच्छा, नहीं, why is it H2NO2? हाँ ठीक है, so it is methanoic acid. इसके अंदर भी there is serial bond हो, so that will do it. ये क्या होगा? CH4, इसका फिगर आउट कर. CH4, how would CH4 बीच में you have to fit an O as well, तो probably OH ही होगा. That's the only way that's possible. This does not have serial bond O, तो P जो है ना वो गलत है. It's only going to be Q and R. Is that clear?
Yes, sir.
तो इन दोनों में सीरियल बॉन्ड वो आ रहा था. ठीक है, तो इसलिए वो है. So let's open another paper कि we have 18 कर लेते हैं. ठीक है, बस छोटे छोटे क्वेश्चंस. कोई वो वाला क्वेश्चन वैसे ऑर्गेनिक के साथ मिल के आएगा तो मुश्किल होगा. अच्छा, ये आ गया infrared spectrum. ये क्या है? कौन सा बॉन्ड है इसमें? नहीं, कोई बता दे क्या ये absorption. आयशा, which bond is this? मुनीब,
Sir, I'm not sure.
नहीं, 1600 to 1600
The
वाली.
double bond O.
ठीक है, so that's a serial bond and only serial bond O. There is no OH. ठीक है, वो OH गायब है. ये वैसे ही याद रख लो, मतलब OH और serial bond O वैसे ही याद रख लो, डेटा बुकलेट खोलने की भी जरूरत ना पड़े. 2500, 3000 strong and very broad और strong and sharp. ठीक है, तो there's nothing. वो weak C है, वो CH की होगी probably. ठीक है, तो किधर चला गया क्वेश्चन? यहाँ पे एक सेकंड, क्वेश्चन ही गायब हो गया। हाँ ये वाला सीरियल बॉन्ड हो। अच्छा, सो देयर इज नो OH, वो तो क्लियर हो गया, देयर इज नो OH, ठीक है। तो which compound could give this spectrum? So only has serial bond O, so it's going to be C, क्योंकि OH आ गया, it can't have OH, carboxylic acid, OH वो सारे निकल गए। क्लियर है? मतलब बहुत आसान है वो वाला क्वेश्चन, वो अच्छा था कि वो थोड़ा मुश्किल था because they had linked it up with organic, but this one is kind of easy. चलिए, is this clear? Infrared spectrum clear है?
Yes, sir.
Yes, sir.
तो हर पेपर में ना एक MCQ कहीं ना कहीं बीच में फिट हुआ होगा। अच्छा, इसमें भी वो जो ओरिजिनल जो क्वेश्चन था ना हमारा, जो सबसे पहला वाला था ये वाला, इसमें घबराने की कोई बात नहीं थी। जस्ट रिमेम्बर के इफ यू हैड फिगर आउट उसके अंदर even the whole reaction scheme you weren't supposed to, elimination से निकल आता था, ठीक है, कि this was a ketone, so it must be a ketone, and this other one was clearly a carboxylic acid. It's got a serial bond O and it's got an OH that belongs to a carboxylic acid, broad absorption. तो that was, वो उसी तरह निकल आ गया था, वो बाकी एलिमिनेट हो गए थे, उसका X का पता करने की जरूरत ही नहीं थी आपको। So even this question was kind of simple. If you can just identify whether it has serial bond O or not, whether it's got OH or not. तो ठीक है, infrared spectrum we're done with it, ठीक है। तो बाकी पे past paper questions और करते हैं, ठीक है। Maheen, do you have any specific topics that you want to study? Yeah, do you want to do past papers?
Past papers.
ठीक है, चलो ठीक है, we'll be doing past papers. I mean, we're pretty much done with almost all things. We'll be focusing on past papers, ठीक है। चलें, okay, everyone.
Sir,
Oh, yes.
All right, sir. Love.
Okay, हाँ जी
sir,
आयशा,
have a lecture before than that.
इससे पिछला वाला ठीक है मैं कर लेता हूँ, वो मेरे ख्याल से mass spectrum वाला था, तो मैं ढूंढता हूँ, ठीक है।
Sir,
Yes.
actually, it would be great if you could go through like equilibria questions.
ठीक है, I mean we can either do like if you have specific topical problems, so we can do those topic related questions first, तो topic clear हो जाएगा, and then we can do the whole past papers as well, ठीक है।
Yeah, okay, sir. Thank you.
चलो, okay, अल्लाह हाफ़िज़।